Okay, let's start off and cover some cryptographic terminology. All right, sounds like fun, doesn't it? So, starting off, cryptography, what is that? Well, that is the practice and the study of hiding information. Okay, cryptography is actually a pretty old science, if you will, part art, part science. It dates back 4,000 years. Okay, we'll cover that in a moment. Next, we have cryptanalysis, and that is discovering some weakness or an insecurity in cryptography, all right, or a cryptographic scheme. So basically, we're looking for some hole or vulnerability or a chink in the armor, so to speak. And so we have two kind of competing technologies or competing sciences here. We have one who is the cryptographer, and that person is trying to hide information. And then the person who's tasked with cryptanalysis, they're actually trying to discover some weakness in that cryptographic scheme. Next, we have encryption, and that is the method of transforming data, typically which is plain text, into an unreadable format. Then we have plain text, which is, again, the readable format of data before being encrypted. Okay, and these are just some words that you should be familiar with when we're having our discussion on cryptography. Okay, next we have ciphertext, and that is the scrambled, quote-unquote, format of data after it's encrypted. All right, so we have the plain text, which is the human readable form. We're going to apply some cryptographic algorithm or cipher, right, turning it into ciphertext. And that scrambled data then, again, is human unreadable. We need to have some method of decrypting that. And that's where we come in with decryption. All right, that's the method of turning that ciphertext that we just talked about back into plain text, back into that human readable form. Next is the encryption algorithm, and that is a set of rules or procedures that's going to define how we actually encrypt and decrypt the data. All right, and that's known as the encryption cipher. And we'll talk about a few different ways of doing that, whether it's asymmetric, symmetric, block versus stream, and so forth. We'll cover those in more detail in just a few moments. Next, the concept of a key, and that's a value used in the encryption process to encrypt and also to decrypt data, otherwise known as a crypto variable. Okay, so just a brief bit of cryptography history. Cryptography is actually over 4,000 years old. So it predates actually a lot of languages itself. So it predates computers, obviously. Okay, electronics or any technology. I don't think there was anybody walking around with iPhones or even Walkmans back 4,000 years ago. So cryptography is a very old way of hiding information from one another. And then the earlier cryptographers relied on methods simply to scramble text, otherwise known as a cipher. And they used something called a substitution cipher or a transposition cipher. Right? It didn't advance to the point where we have mathematical algorithms like we do now in elliptic curve and quantum cryptography, which we'll talk about later in this module. But back in those days, in the early days, it was simply just substituting like an A for a B, moving things left or right, a certain number of characters. So if we look at a substitution cipher as an example, that's changing one character for another. All right, now Caesar, otherwise known as a Caesar cipher or a shift cipher, Julius Caesar was one of the first cryptographers or one of the first people that actually, I should say, implemented cryptography. And that was the process of shifting all the letters a certain number of spaces in the alphabet. All right, so as you see here, the alphabet is shifted by 3 spaces. So A would be X, B equals Y, C equals Z, and so on and so forth. All right, so we're shifting everything 3 spaces. Next is something referred to as ROT 13 or rotation 13, and that is basically a substitution cipher as well that's going to rotate letters 13 spaces. All right, so again, not extremely sophisticated. If we know the encryption algorithm, in this case ROT 13, it's very easy to go backwards. Once you have the scrambled text, we can decipher that relatively easily.